Good morning, everyone. I hope you guys had a great weekend and a good day off on Friday. I'm working on writing your report cards. I'm still not sure how we're going to get them to you guys, but don't worry. You will see your report cards at some point. A couple announcements before we get started. So this week, we're going to start on week 5 packet. So this is what the packet looks like. We're doing week 5. If you were able to do day 5 of week 4 on your own, then great. If you weren't, don't worry about it. Everybody's going to move on to week 5. Now we're starting to look ahead to week 6 and 7. So you guys are going to pick up those packets outside of Tubman on Tuesday and Wednesday. So Tuesday starting at noon, so 12 p.m., you guys can pick up your new packets from Tubman week 6 and 7. We're going to start with week 6 next Monday. So it's so important that you pick up your packets. Okay, so let's get started. I'm going to share my screen with you, and we're going to start on the new learning for week 5. So if you can get out your packets while I'm sharing my screen, that would be great. Whoops, let's go back to the top. Okay, so today what we're going to do is we're going to be able to use area models and multiplication to show that two fractions are equivalent. And actually, we've already been doing a little bit of this in the past couple of lessons. And here, I just put an example of a multiplication sentence. So 1/2 times 2/2 equals 2/4. 2/4 and 1/2 are equivalent. And what that means is they're two different fractions that represent the same amount. They're equal to each other. They don't represent different amounts. So that's what equivalent means. Okay, so this one says the shaded unit fractions have been decomposed into smaller units. Express the equivalent fractions in a number sentence using multiplication. So they've already been decomposed for us. So here, we're looking at A, this first one. We can see that the amount that we started with before they decomposed was 1/3. This piece here is 1/3. Then they decomposed with one horizontal line and created 2 rows. So the way that you represent that in your multiplication sentence is 1/3 times 2/2 equals 2/6. Because now I have 2 out of 6 pieces. You may wonder how we knew to multiply times 2/2. Well, you can easily find that by looking at the number of rows. Since they created 2 rows, we're going to multiply times 2/2. Okay, let's look at another example. Same thing here. They started with 1/3. And decomposed into 4 rows. And you can count the rows. 1, 2, 3, 4. So what we're going to do is multiply times 4/4. So we started with 1/3 times 4/4, or 4/4, gives us 4/12. The rule here is, though, you have to multiply the numerator and denominator by the same number. Okay, let's look at the next one. It says decompose the shaded fraction into smaller units using the area model. Express the equivalent fraction in a number sentence using multiplication. So we're decomposing and we're multiplying. So first thing you're going to do is look at, well, what fraction am I starting with? So ignore the dotted lines and count the fraction that you're starting with. So count the number of pieces. 1, 2, 3, 4, 5, 6. So this is 1/6. Then count the number of rows that they created with the dotted lines. So there's 1, 2, 3 rows. So we're going to multiply by 3/3, or 3/3. So 1/6 times 3/3 equals 3/18. As you multiply, the size of the units gets smaller. This is really important. The size of the units gets smaller. So each piece is now smaller than what we started with. but we have more of them. So it kind of balances each other out. You have more pieces, but the pieces are smaller. Before, you had fewer pieces, but the pieces were bigger. So they end up being the same. So this area model shows that 3/18 is equivalent or equals 1/6. Okay, let's go on to the next one. This one says, draw 3 different area models. 3 different area models to represent 1/2. 1/2 is 1/2. By shading. Decompose the shaded fraction into fourths, sixths, and eighths. Use multiplication to show how each fraction is equivalent to 1/2. So we're starting with 3 area models that all represent 1/2. So this is a half, this is a half, and this is a half. The first one, we need to take our 1/2 and change it into fourths. So the way that you can think about this is if you start with 1/2, what do you multiply times 2 to get 4? So I have a half. What do I need to multiply by so that it will equal 4 in my denominator? So 2 times is 4. Well, 2 times 2 is 4. So we know that we're going to multiply by 2/2. And what that looks like in the area model is we're making 2 rows. So we decompose with 1 line through the middle. Okay, so the same thing with 1/2. We want to make it into sixths. So you asked yourself, what do you multiply times 2 to get to 6? And that's 3. So you decompose it into 3 rows. That's drawing 2 horizontal lines or 3 rows. So count the rows. 1, 2, 3 rows, and that will give you sixths. Same thing over here. You start with a half. You ask yourself, we want to make eighths this time. What do you multiply times 2 to get 8? And that's 4. 2 times 4 is 8. So you make 4 rows. All right, and each one, the number of units is doubled. So we started with 2 units, then we got 4 units. Here, the number of units is tripled. We started with 2 units and we got 6 units because we multiplied times 3. And the number of units is quadrupled. We started with 2 and we ended up with 8, quadrupled because we multiplied times 4. Okay, let's look at this one. The shaded fraction has been decomposed into smaller units. Express the equivalent fraction in a number sentence using multiplication. So this time we're starting with the area model and we have to write the multiplication sentence. So I know the answer is given to you right here, but I'm going to show you how they figured that out. So the first step is you need to look at how much was shaded before the decomposing happened. So we have 1, 2, 3, 4, 5 pieces total. So that's our denominator. It's fifths. And 2 of them are shaded. So my fraction is 2/5. Then you look at, well, how many rows did they make when they decomposed? They drew 1 dotted line through the middle, making 2 rows. So we know that we're multiplying times 2/2. Times 2/2. Oops, way too big. I think I've been doing a little better with the drawing than I was in the beginning, but we'll see. Times 2/2. And do the multiplication. 2 times 2 is 4. 5 times 2 is 10. And count if that's true. So 1, 2, 3, 4 are shaded. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total. So it's right. Let's go to this one. Decompose both shaded fractions into sixteenths. So we have 2 fractions and we want to make them both into sixteenths. Express the equivalent fraction in a number sentence using multiplication. So again, I know the answers are right there in front of you, but I'm going to show you how to think about it. So for this one, they're telling us that we're starting with 3/8. And we know that we want to multiply it to get times something to get 16ths. So we have to ask ourselves, what do we multiply times 8 to get 16? Well, 8 times 2 is 16. So whatever we do to the denominator, we also have to do to the numerator. So, we multiply the numerator times 2 also. 3 times 2 is 6, so that's 6/16. Now, since we know we have to multiply times 2/2, that means we're going to make 2 rows. So we draw that one line through the middle to create 2 rows, and it makes 16 pieces. So let's do the same thing over here, the same process. So we start with 2/4. And the rule for this one is they want 16ths. So how do we turn 2/4 into 16ths? Well, here's what we do. We ask ourselves, what do I need to multiply 4 by to get 16? So I know that 4 times 4 is 16. Whatever we do to the denominator, we do to the numerator. So 4 times 4 is 16. 2 times 4 is 8. So the gap gives us 8/16. Now to the model. So since we multiply times 4/4, we're going to create 4 rows. 1, 2, 3, 4. 3 lines makes 4 rows, and that gives us 16ths. So I think it's a little bit easier to start with the multiplication, but if you're not sure about the multiplication facts, experiment with the model. Decompose the model and see how many rows you need to make to get to 16. Okay, this time we're just using multiplication to create an equivalent fraction for 8/6. Ooh, this time we have a fraction greater than 1. Now I know that if we were in class, you guys would be so happy about this because you wouldn't have to draw any more models and you'd just be able to use multiplication, which I know you all think is way faster. So it just says create an equivalent fraction, so it doesn't tell us what our fraction has to be. So you can choose any fraction that's equivalent to 1 whole. That means the numerator and denominator is the same. So here they say, you know, you can really choose anything. 3/3, 4/4, 5/5. So over here in the example, they chose 2/2 or 2/2, but let's do a different one over here. So we start with 8/6. And let's do times 3/3, or 3/3. So 6 times 3 is 18. 8 times 3 is 24. So we have 24/18. So what they're trying to show you here is that this strategy also works with fractions greater than 1 whole. So this one says, determine if the following is a true number sentence. So this is true or false. Correct it if it's false by changing the right-hand side of the number sentence. So let's take a look. They're saying that 5/4 is equivalent to 15/16. So the way that we can think about this is ask ourselves, well, what did they multiply times 4 to get 16? That was 4 times 4. Did they also multiply the numerator times 4? 5 times 4 is not 15, so it's false. The numerator was multiplied by 3, and the denominator was multiplied by 4. 3/4 is not a fraction equal to 1 whole. So they didn't multiply the numerator and denominator by the same number. So over here, they corrected it. So instead of multiplying the denominator by 4, they multiplied it by 3/3 to make it right. So 5/4 times 3 is 15/12. This is the correct answer. All right, let's move on to the let's try it. So at this point, you guys need to take out your packets and turn to this page. And I'll give you a second to get your packet, but you should all be on this page and we're gonna be doing it together. So you should have a paper and pencil filling it in with me. Okay. The shaded unit fractions have been decomposed into smaller units. Express the equivalent fraction in a number sentence using multiplication. So what we're doing is we're looking at the model and we're writing the multiplication sentence. So we started with a half, and then they drew one line through the middle and made 2 rows. So we know we're going to take 1/2 and multiply times 2/2 because we have 2 rows. So you guys should be writing this in too. So 1 times 2 is 2. 2 times 2 is 4. So my new fraction is 2/4. What is the multiplication sentence? I'm not going to rewrite it because it's right here. That answer goes in there. What happened to the size of the fractional unit when you multiplied? So we started with halves and we ended with fourths. So those are the fractional units. I want you to think about the size. What's a larger fractional unit? Halves or fourths? Well, fourths is a smaller unit. So when we multiplied, we got a smaller unit. So what happened to the size of the fractional unit when we multiplied? It got smaller. So we can write in here, it got smaller. Or you can say, it decreased. If you're looking for a math word. So fill that in. Correct my spelling. Okay. What do you predict would happen to the shaded fraction if we tripled the unit? So if we tripled it, meaning we made 3 rows, well, it would become sixths, and sixths are even smaller. So we would get sixths, and sixths are a smaller unit. So it would still, the unit would get smaller and the number of pieces would get bigger. So you guys can write that down in your own time. Let's move on to the next one. Here, it says, what's the relationship? We're going to do the same thing. So let's first decide what fraction we started with. This time they're not giving us the fraction we started with, they're only giving us the fraction we're ending with. But we can look at it and imagine the dotted line isn't there and know that we had 2/3. So fill in 2/3. So what do we multiply 2/3 by to get 4/6? Well, here, so 2/3, they made 2 rows, so it's times 2/2 again. What is the relationship of the numerator, the fractional unit selected, in the equivalent fraction? I think what they mean to say is, what's the relationship between the numerators and the equivalent fractions? So the relationship is the number of pieces shaded doubled. The denominators also doubled. So in the second one, they're asking us what the relationship is between the denominators or the fractional units. Well, both of them doubled. And I'm going to write that in for you. Doubled. And that's because we multiplied by 2. What happened to the number of units in the whole? They doubled also. But the shaded part stayed the same. So the number of pieces and the size of the pieces, so that both of them doubled, but the total shaded part stayed the same. So the way that this is written is a little bit confusing. All right, I want you to move on to your problem set on your own. And if you have any questions, you can comment on this video or you can call me. We have a math lesson today at 2 o'clock, and remember this time I'm taking attendance. So all of you guys should be there, log into Teams at 2 o'clock, and we will go over this. All right, I will see you guys at 2.